All right, so this is section 5, box and whisker plot. So you may have heard of box and whisker plots before, or they have also maybe called a box plot. So a box and whisker plot gives us a 5-number summary of a data set. And these are the 5 pieces of data you get. Number 1 is the minimum number, so the smallest number in the data set. Number 2, you get the maximum number in the data set. Number 3, you get the median. It's also known as Q2, so that 2 is a subscript down next to the little tail of the Q. So Q2, or the second quartile. Q stands for quartile. The 4th piece of data you get is the upper quartile, or Q1. I have that backwards. The upper quartile is Q3. Let me fix that. Then the lower quartile is Q1. All right, so again, Q stands for quartile. When you think of quartile, you should be thinking of 25%. So a box and whisker plot is going to divide your data set into 4 parts, okay? So let's look at this box and whisker plot and label all of the parts so we can see what everything is. So this in red is your box and whisker, or your box plot. This first dot down here is known as the minimum number. This second dot, the edge of the box, is Q1. Center here is Q2, also known as the median, okay? Q3, and the maximum. Some box and whisker plots also show outliers. Outlier is a piece of data that's an extreme value, a lot smaller or a lot larger compared to the rest of the data set. All right, so on this box and whisker plot, this dot out here by itself, that's the outlier. Then the next dot then is the next minimum, not including the outlier. Now, these 2 red boxes right now, they're looking pretty symmetrical. When I was in school, I thought that I was making the box and whisker plot wrong if these boxes were not symmetrical. Sometimes those boxes can be extreme, like this box could be really small and this one could be really big. And that is actually the key of a box and whisker plot. It's showing you where the concentrated values are. It can be just as informative as a histogram if you understand what's being shown. So when you have tall bars on your histogram, there's a lot of data there that's concentrated. So when you have a box and whisker plot and this section is really short, that means there's a lot of data right there in a short amount of space. So it's the opposite, okay? The tall histogram bars is where there's a lot of data. And so you have 4 areas. You have whisker, box, box, whisker. And if any of those 4 areas are really short compared to your number line, there's a heavy concentrated data. Okay, so let's talk about one more thing. Interquartile range. It's also abbreviated IQR. Write this down, please. You need to add it on your note guide. I don't have a blank for it, so right below that box and whisker plot. Interquartile range. That's when you take quartile 3 minus quartile 1. And interquartile range can be abbreviated IQR. So I've been just kind of telling you a lot of stuff about the box and whisker plot, throwing a lot of vocabulary at you. These are the steps, okay? So, first of all, an outlier. To calculate if your data set has an outlier, it's going to be any data point that is more than 1.5 times, so 1.5 times the interquartile range, above or below quartiles 1 and 3. So this is how you mathematically calculate a quartile, or excuse me, an outlier. You would take quartile 1 minus 1.5 times your IQR. That's known then as your lower limit. How low can my data set be before a new piece of data is an outlier? And then the upper quartile, or the upper limit, is found by taking quartile 3 plus 1.5 times the IQR. So you need to commit to memory 1.5 times IQR. So again, IQR was interquartile range that we would subtract to get the IQR. So to make a box and whisker plot, you have your 5 steps, okay? So find the median, okay? Median is the middle number. Number 2 says find quartile 1, or the lower quartile. That is the median of the bottom half. Quartile 1 is the median of the bottom half of the data. So when you find the median, step number 1, when you find that median, you are dividing your data set into 2 halves. So then step 2, quartile 1, this is the median of the lower half. Step number 3, the quartile 3, the upper quartile, that is the median of the upper half. Step 4, we'll test for outliers. Okay, remember that IQR, okay, that's your upper median, so Q3 minus Q1, okay? And then we'll graph the information. You make a number line to graph your information. You're going to make a number line, and that's why I told you to grab a ruler, okay? We want the number line to be like equally spaced so that we can actually see the concentrated values. If you don't equally space out your numbers, you won't, the box and whisker plot would be meaningless. So we have a couple examples here to practice. So the first step, okay, the first step when you're given a data set is you need to put them in order least to greatest. So it's not super fun to make a box and whisker plot if you have too much data. Go ahead, please, and list these numbers least to greatest for me. Obviously, as you're going through here, sometimes it helps to kind of cross them off as you write them down. And hopefully this goes without saying. Count the number of original data pieces you have, and then count the number of pieces when you put them in order. Make sure you didn't skip anything. You would hate to do the whole entire box and whisker plot wrong just because you didn't rewrite this list correctly. Does everyone agree with my box and whisker plot list? Okay, 2, 4, 5, 7, 8, 9, 10, 11, 16, and 21. So when I'm looking at this, I'm thinking, oh, these numbers are pretty close together. Maybe 21's a lot bigger than the rest of the data set. 2 isn't very far away from this, so I might have an outlier, I might not. Okay, that's kind of the things that you're thinking about as you're going through here. Okay, so immediately we need to divide our data in half. So step 1 is to find the median. So I count how many pieces of data here do we have? 10? So halfway through is going to be between our 9 and 10. Oh, nope. Between the 8 and 9. Correct. All right, so between 8 and 9, and so what is our median? Okay, so our median is in between the data values that are there. Use the 8 for the bottom half and use the 9 in the top half. If you ever find the median, and let's say the median here would have been 9, you wouldn't use the 9 in the top half and the bottom half. And we'll do an example like that here in a minute. So my median is 8.5, so that is Q2. What would be my median of the lower half? 5. So that is Q1. And then the median of my top half. And my minimum number is right now 2. My maximum number right now is 21. If we were not testing for outliers, we'd technically be done, but we need to test for outliers. Okay? So the first step here, if we want to write this stuff down over here, we do know that our Q1 is 5, Q2 is 8.5, and Q3 is 11. Now LL, that's lower limit, okay? And UL is our upper limit. Let's go ahead and write here IQR. What would our IQR be? That's going to be Q3 minus Q1, so our IQR is 6. So then to find our lower limit, we're going to take our IQR times what? 1.5. 1.5, okay? And we're going to subtract it. So you want to know how low can I go here? So it's going to be Q1, right? So 5 minus 1.5 times 6. Okay? Is it a positive 9? Okay, so 1.5 times 6 is 9. Thank you. So then 5 minus 9 is negative 4. Okay? So that is correct that you get a negative here. Think about like where your lowest data point is 4. Or excuse me, it's 2. So if you had values that even went lower, they'd have to be a negative before they'd become an outlier. Okay? Now on my upper limit, I'm going to start at Q3, which is 11, and I want to be, my upper limit is going to be 1.5 times bigger than that upper limit for my Q3. So 11 plus 1.5 times 11. Nope. Times 6. As soon as I wrote that, I'm like, that was wrong. So again, 1.5 times 6 is 9. So 11 plus 9 is 20. Okay. So what's my outlier? 21. So I'm going to put a little star here. Okay. 21 is now my outlier. So my maximum, the end of my whisker is going to be the 16. Okay? All right, so I have a number line drawn up here. Your number line is not tick marked. If we go by 2's, 0 to 24, you would need 12 tick marks. So if you put your ruler on your number line, maybe you'd want to use like centimeters. Could you get 12 tick marks there, evenly spaced with your ruler? Maybe every centimeter put a tick mark. Okay? So you just really need 12 or 13 tick marks there. Go from 0 to 24 or 2 to 24. Give yourself some space. I'm going to go ahead and label my number line and you can do yours. So I'm labeling every other tick mark because I can't write small enough. So our minimum is 2. I like to just put all of my dots out there. So I'm putting a dot at 2, 5, 8.5, 11, and my maximum now is 16. Okay? And so we know that here then would be my whisker. I draw in my box. And then my whisker. And then you want to put a dot at your outlier. So again here, my box is not symmetrical. I have an evenly spaced number line. My box is not symmetrical, and it's showing me that I have concentrated data here in that area. My whisker's long, looking from like 9 to 16, that's a bigger amount of space, so that whisker would be longer than my lower whisker here. And so you can start to analyze the data by looking at the length of the whiskers in the boxes. What questions do we have so far? All right, so example number 3. Let's make the box and whisker plot with this new set of data. First step, take all your numbers and put them in order. Take 15 seconds here and put the next set of data in order. All right, so I have 10, 25, 27, 39, 46, 50, 56, 56, 92. Do I have any mistakes before we get started? Okay, so how many pieces of data do we have? Okay, so the median is 46. Okay, so now I don't use the 46 to find now my next median. Okay, so I'm only looking at 39 through 10. What's the median of my lower half? 26. Good. Again, ignore that 46. Now my median of the upper half is 56. So in between there. My calibration must be slightly off. Okay. Now, we need our IQR. 56 minus 26. So my Q1 was 26, 46, 56. Lower limit is going to be 26 minus 1.5 times 30. Minus 45. So what's our lower limit? Negative 19. And then 56 plus 1.5 times 30. 101. Do you agree? Okay. So we don't have any values below negative 19 or above 101. So we have no outliers on this data set. Okay? Yep. All right, so when I think about where you need to space this out, I'm going from like 10 to 95. I went by fives. Did that give you enough? If you're going by centimeters, can you space that out good enough? You might have to go by 10. Do you have to go by tens if you do a whole centimeter? Okay. So my smallest data point here, my minimum was 10. My maximum is 92. So we're just going to estimate out where this stuff falls. So 10, 26, 46, 56, 92. So if it helps, you can maybe draw your box in the center. Whatever order you do that in is fine. Tail, or whisker, and whisker. And so again, our box is not symmetrical, and that is what shows us this data is not normal distribution. Honestly, if your whiskers and your boxes are all the same length, your data would have had normal distribution. Like all of the data would have been like equally kind of spaced out. Well, I take that back. Your boxes would be symmetrical, but your whiskers don't have to be the same length. Some normal distribution would have whiskers and boxes the same. But the whiskers would be the same and the box would be the same if your data was concentrated in the middle. Okay? So that wraps up our box and whisker notes